from the analog communication, one of the very important topic is modulation. So to transmit the signal from one place to another place up to long distance, modulation process is used. So first of all, we will go through the definition of the modulation and the basic block diagram of the modulation and what is the necessity of the modulation, and later I will explain the different modulation techniques. Modulation is the process of changing characteristic parameter of carrier signal with respect to amplitude of the modulating signal. First of all, I will draw the basic block diagram of the modulator. Later, I will explain the definition of the modulation. Modulator, the function is used to convert low frequency signals into high frequency signals. Carrier signal, right? So our general available information, the general available information or input of the modulator is called modulating signal. Modulating signals are general available signals like voice signal, audio signal and video signal. Already we have discussed the frequency ranges of the voice signal, audio signal and video signals. So the maximum frequency of the video signal is 4.5 megahertz, audio signal is 20 kilohertz and voice signal, that is speech signal, is 3.4 kilohertz, and these frequencies are low frequency signals, low frequency, because this information can transmit up to certain distance. But according to the real-time application, we have to transmit this low frequency signals to up to long distance. Up to long distance, I want to transmit my voice signal to the up to long distance, 1000 kilometers and 100 kilometers, right? So 10 kilometers. So depends on the distance. Here we have to combine this available information with another signal, that is carrier signal. This name explains it carries the information from one place to another place. So the function of the carrier signal is it has to carry this modulating signal. It has to carry the modulating signal from one place to another place. That's why the name of the signal is here carrier signal, and carrier signal should be always high frequency signal, because the function of the carrier signal is it has to carry the information. It has to carry this information from one place to another place. To carry that information purpose, it requires very high frequency. The frequency should be more than the modulating signal frequency. Then only it can transmit the signal from one place to another place. Up to long distance communication is possible. So the carrier carries the information from one place to another place. So your information is nothing but your modulating signal. And finally, this modulation process performs the complete operation. Then later, which gives the one signal. This signal is also called as modulated signal. Modulated signal. See, input of the modulator is modulating signal. Output of the modulator is modulated signal. Modulated signal. So modulated signal is now high frequency signal or a low frequency signal? Is it a high frequency or low frequency? This should be high frequency signal, because this complete information combines with this information. This carrier signal is a high frequency signal. So low frequency signal combines with high frequency signal. Then finally the output signal consists here high frequency signal. Without changing the information, this signal has to carry this information from one place to another place. That is the function of the carrier signal. So that's why the carrier signal is always high frequency signal. But generally available signals are low frequency signals. Just now we have discussed the voice signal, audio signal, video signal, frequencies are low frequency. But how to you generate this carrier signal? To generate the carrier signal, separate electronic circuit is used. That electronic circuit is oscillator. But here our requirement is a high frequency signal. That's why we have to use here high frequency oscillators. So that oscillator has to generate very high frequency signals. Generally used high frequency oscillators are LC oscillators or crystal oscillators. But here in communication systems and in this process, generally here we have to call it as a local oscillator. So The name of this one is here local oscillator. Local oscillator is used to generate the carrier signal. So what is the meaning of the local oscillator? The local oscillator is nothing but it is an oscillator which is used to generate the desired frequency according to the circuit requirement. If this modulator requires in terms of megahertz frequency, then the oscillator generates the megahertz frequency. If this modulator circuit requires in terms of 100 megahertz, then the oscillator generates the in terms of 100 megahertz signal. So an oscillator generates the high frequency signal. If the oscillator generates the high frequency signals according to the circuit requirement, then the oscillator is called local oscillator. So that's why here always we have to use local oscillator name representation. So local oscillator is used to generate high frequency signal. That signal is also called as carrier signal. So the modulator requires completely two input signals. One signal is called the modulating signal and another signal is called carrier signal. Then it combines these two, then finally which gives the modulated signal. That modulated signal is a high frequency signal. That's why here I have wrote one simple point. Modulator is used to convert low frequency to high frequency. Low frequency signals into high frequency signal without changing the internal parameters of the low frequency signal. So for that purpose here we have to write the standard definition of the modulation process, right? So now here I am writing modulation. The complete communication system depends on this definition. So you have to remember this definition compulsory. It is the process of changing characteristic parameter of carrier signal. Carrier signal means this signal. So we are not changing this part. This signal should be as it is. Without changing the internal parameter of the modulating signal, we have to transmit this signal from one place to another place. That is the main function of the modulation process, right? So it has to convert from low frequency to high frequency. That is the main function of the modulation process. So for that purpose, the definition explains here, it is the process of changing characteristic parameter of the carrier signal with respect to amplitude of the modulating signal. So with respect to amplitude of the modulating signal, if the amplitude of the modulating signal is increases or decreases, then automatically this carrier signal characteristic parameter has to increase or decrease. That is completely depends on which parameter? Amplitude of the modulating signal. That's why here I have wrote a characteristic parameter is nothing but here amplitude or frequency or phase of the carrier signal. This is the basic block diagram of the modulator, and this explains the modulation process simple example. Right? Now we have to discuss what is the necessity of the modulation to transmit up to long distance. See, already I have explained one example. That example is a person wants to go up to 1 kilometer. So transportation is not required. If the same person wants to go up to 10 kilometers distance. So one person has to go from one place to another place, and the distance between the two source and destination part is 10 kilometers, then compulsory he has to use one transportation, right? That is either bike or some other car or any other bus. And the same person wants to go up to 100 kilometers, so compulsory had to use some other carrier part, some other transportation, that is bus or train. So the bus, train and this bike or car, all these are comes under carriers, because these devices, these elements carries the person from one place to another place. So a car carries the person from one place to another place. A train carries the person from one place to another place. So all these are comes under carriers. So now the simple name here I have wrote carrier signal. That's why I have wrote here carrier signal is high frequency signal. So what is the necessity? Because this low frequency signal can transmit up to certain distance. Direct transmission is up to certain distance is possible. That distance is very short distance. To transmit up to long distance, so compulsory it requires very high frequency signal. That's why the speed of the bus and speed of the train is compared to the person, very high speed devices are used, high speed transportations are used, right? Similarly here, the frequency of the carrier signal should be very high frequency, then only the signal carries this information from one place to another place. Depends on the distance, depends on the modulation process. We have to use different types of carrier signals, different frequency ranges. That is depends on the modulation process, that is depends on the application process. So here I wrote simple high frequency, that frequency range is any range. So that part we have to discuss now, in which modulation technique the frequency range is defined, particular ranges. So why it is defined in that range, and what happens if it is other than that range. All this we have to discuss now. So the complete communication subject deals with these topics. Now we have to discuss here need for modulation. The main aim of the modulation is for long distance communication. The main application is here for long distance communication, because we have to transmit our signal, our voice signal or our information up to long distance. So the main aim of the modulation process is for long distance communication. For long distance communication, what happens here? Low frequency signals are converted into high frequency signals, right? So due to that high frequency signals, then automatically antenna height is used to convert. Antenna is used to convert electrical signals into electromagnetic waves and electromagnetic waves into electrical signals. That is depends on the application. So which is converted into one form to another form. Electrical to electromagnetic waves and electromagnetic waves into electrical signals. So the all the signals are transmitted in the form of electromagnetic waves. So that is comes under in terms of wireless communication. So to receive those signals, antennas are used. Now antenna height is reduces due to this modulation process, because antenna height is always depends on the wavelength. So antenna height, just I am assuming here h. So antenna height is always depends on the wavelength. The standard mathematical equation is defined like this. Antenna height is directly proportional to lambda by 4. So this is lambda. Lambda is nothing but wavelength, right? This is wavelength. So the antenna height is always directly proportional to the wavelength. If the wavelength is very high, antenna height is also very high. And the wavelength and frequency, these two are inversely proportional. So we can write like this. This is another standard equation. Wavelength lambda is equal to c by f. What is c here? C is a light velocity, that is 3 into 10 to the power of 8 meters per second. 3 into 10 to the power of 8 meters per second. That explains the light velocity. And what about f? F is frequency. F is frequency in hertz, right? So the frequency and lambda, these two are inversely proportional. If the frequency is very high, lambda value is very less. If the lambda value is very less, then automatically height of the antenna is less, right? So if the frequency is very high, antenna height is reduces. This is one of the important application of the modulation process. So for easy understanding purpose, now I am taking one frequency is 3 kilohertz. Let us take the frequency of the signal is 3 kilohertz. Then the lambda value is how much now? 3 into 10 to the power of 8 by 3 into kilo is 10 to the power of 3. Now it becomes how much here? 10 to the power of 5. 10 to the power of 5 meters. So if the wavelength is 10 to the power of 5 meters, so what is the expected of height of the antenna? The height of the antenna is approximately here 25 kilometers. So to receive or to transmit this frequency signal, this range frequency signal, the antenna height required here 25 kilometers antenna height is required. If the frequency of the signal is increases, automatically antenna height is reduces. This is another application of another advantage of modulation process. Antenna height is reduces, right? And it has another advantage. That advantage is multiplexing is possible. More than the one informations are transmitted through the single channel. So here one information, and here another information, and here one more information. All these are transmitted through the single channel. all these are more than the one informations are transmitted through a single channel. This process is called multiplexing. So multiplexing is possible using modulation process, because here we can use the same carrier signal for different informations, and there are different types of multiplexings also there that we will discuss in later. So here, due to this modulation process, multiplexing is possible. This is also one of the advantage of modulation process, right? And another advantage is noise and distortions or decreases. Noise and distortions or decreases. If the frequency is connected from low frequency to high frequency, the same carrier frequency carries the more than the one information, so automatically noise and distortions are decreases due to this modulation process. So all these are comes under advantages of the modulation process. We can write some other advantages also. Here I have wrote the main advantages. This modulation process is used for long distance communication, and due to this modulation process, antenna height is reduces, and multiplexing is possible due to modulation process, and noise and distortions are decreases. So here in this video, just I have explained what is modulation and what is the necessity of the modulation, and later we have to discuss the types of the modulation process. So, according to the carrier signal, the modulation process is classified into two types. One is called continuous wave modulation and another is called pulse wave modulation. So just now I have explained the modulation process is it is the process of changing characteristic parameter of the carrier signal. If the carrier signal is continuous wave signal, then the modulation process is called continuous wave modulation. Continuous wave signal should be like this. Now let us assume one sinusoidal signal. This is considered continuous wave signal. The amplitude and the time both are in continuous representation. Both are as infinite number of combinations. Amplitude and time both are infinite number of combinations. Then the signal is called continuous wave signal. So continuous time signal. Now if the carrier signal is continuous wave signal, then the modulation process is called continuous wave modulation. And if the carrier signal is pulse signal, here the time axis is divided discrete, right? But amplitude is continuous. That means the signal is available in this format here. Continuous, time axis is continuous but amplitude is discrete. This time axis is continuous but amplitude is discrete. Amplitude has only few levels, high level and low level. These type of signals are called pulse signal. If you assume the carrier signal as a pulse signal, if you takes the carrier signal as a pulse signal in this shape, then the modulation process is called pulse modulation. And if the carrier signal is in terms of continuous wave signal, then the modulation process is called continuous wave modulation. So in this continuous wave modulation, generally we have to use your standard sinusoidal signal. Standard sinusoidal signal. Then the standard sinusoidal signal mathematical equation explains A sine or cos. Anyone is there? A sine or cos of omega t plus or minus phi. So this is the standard representation of the sinusoidal signal, functional representation of the sinusoidal signal. So here A explains the amplitude of the sinusoidal signal, and this omega explains the frequency of the sinusoidal signal, and this phi explains the phase difference of the signal. So totally internally two parameters are there. One parameter is amplitude part and this part is called angle. So this complete part is called angle of the signal and this is called amplitude of the signal. So according to the modulation definition, the process of changing characteristic parameter, the characteristic parameter is either amplitude or angle. If the amplitude of the carrier signal is changes with respect to amplitude of the modulating signal, then the modulation process is called amplitude modulation. Amplitude of the carrier signal is changes, only this parameter is changes. This should be constant. If you changes one parameter, other parameter should be constant here. So amplitude of the carrier signal is changes, then the process is called amplitude modulation. If the angle of the carrier signal is changes, then the modulation process is called angle modulation. This amplitude modulation is also called as AM, amplitude modulation. And don't write AM here, because within this angle again internally two parameters are there. One is frequency and another is phase. So frequency explains the 2 pi of this omega here. Omega is nothing but angular frequency. Angular frequency explains the radians per second. So radians part is called angles and per second part is called frequency. So internally it has two parameters. One is frequency and another is phase. If the frequency of the carrier signal changes, that means here the angle part is changes. So if the angle part changes, what happens? This amplitude part should be constant. We have to change only one parameter. Angle is changes, amplitude is constant, then the modulation process is called angle modulation. So within this angle again two parameters are there. One is frequency. If the frequency of the carrier signal is changes, then the modulation process is called frequency modulation. If the phase of the carrier signal is changes, then the modulation process is called phase modulation. So again it is classified into two types. One is called FM, frequency modulation, and another is called PM, phase modulation. Come to the internal modulation index, this is classified into two types. One is called narrow band FM and another is called wide band FM. Now similarly in this phase modulation again two types are there, narrow band FM and another is called narrow band PM and another is wide band PM. So frequency modulation and phase modulation again classified into two types, narrow band and wide band, that is depends on the bandwidth of the signal. Bandwidth means there we have to consider modulation index, right? And here one more type is there, that is amplitude modulation. In this amplitude modulation we have to discuss some other topics here, because this amplitude modulation directly it has few limitations. To avoid those limitations, some other modulation techniques are introduced. Those techniques are DSBSC, double sideband suppressed carrier, and another is SSBSC, single sideband suppressed carrier, and one more also there, that is VSB, vestigial sideband. So all these are comes under amplitude modulation techniques, because here few drawbacks and few limitations are there. To avoid these limitations of the amplitude modulation, some other techniques are introduced. Those are DSBSC, SSBSC and VSB, vestigial sideband. So these modulation techniques are comes under analog communication. So our subject name is analog communication. This analog communication is completely deals with these topics: amplitude modulation, frequency modulation, phase modulation, and internal types. And each modulation techniques are, modulation graphical representation, functional representation, and power calculations, and important characteristics of the each modulation technique. Generation methods means modulation transmitter circuits and receiver circuits. Receiver circuits are nothing but demodulation techniques and detection techniques, and applications of each modulation process. All these we have to discuss in this analog communication part. So analog communication is completely deals with these topics. And another modulation technique is that there is pulse modulation. That is depends on the carrier signal. If the carrier signal is a pulse signal, then the modulation process is called pulse modulation. And if you take this pulse signal as analog, then the modulation process is called pulse analog modulation. Pulse analog modulation. And if you consider the pulse signal as digital signal means we have to consider in terms of zeros and ones, then the modulation techniques are pulse digital modulation. Pulse analog modulation and pulse digital modulation, that is also again depends on the carrier signal, right? So this pulse analog modulation again classified into two types. If you consider the signal as analog signal, then internally two parameters are there. One parameter is amplitude, another parameter is time. So if the amplitude of the modulating signal is changes, then the modulation process is called pulse amplitude modulation. If the time of the carrier signal is changes, then the modulation process is called pulse time modulation. See here I am explaining one point here. That point is changing characteristic parameter of the carrier signal, not amplitude, modulating signal. Amplitude of the carrier signal is changes. Time of the carrier signal is changes with respect to amplitude of the modulating signal. So we have to change the characteristic parameter of carrier signal only, either amplitude or time. And within the time again two topics are there here. One is position of the pulse and another is width of the pulse. The width of the pulse is increases or decreases, the position of the pulse is also changes. So in pulse time modulation again it is classified into two types. One is pulse width modulation. Pulse width modulation, width of the pulse is changes. It is also called as pulse duration modulation. And other part is their position of the pulse is changes. So pulse position modulation. These topics are comes under pulse analog modulation techniques. And another topic is their pulse digital modulation techniques. In this pulse digital modulation again two types are there. One is called baseband modulation. Baseband modulation. See, baseband modulation, generally we can write the modulation process types here, but specially this topic is used in digital modulation, that's why I am writing there baseband modulation. And another modulation technique is band pass modulation. Band pass modulation process. So in baseband modulation, different techniques are there. Different modulation techniques we have to discuss. Those are pulse code modulation, PCM, delta modulation, adaptive delta modulation, differential pulse code modulation. These are comes under baseband modulation techniques. Pulse code modulation, delta modulation, adaptive delta modulation, differential pulse code modulation. And similarly in band pass modulation techniques, again it is classified into two types. One is called binary and another is called MRA. So those topics directly I am writing here. Those are ASK, FSK, PSK and QPSK, right? And simple name is we can write like this, MRA. All these modulation techniques are comes under band pass modulation techniques. So here I have explained the complete types of the modulation process. Amplitude modulation. First of all, we'll go through the amplitude modulation. Just now we have discussed modulation process introduction and types of the modulation and what is the necessity of the modulation. Now we have to discuss one type of modulation is amplitude modulation. From the modulation, one type of modulation is called amplitude modulation. So amplitude modulation. See, amplitude modulation, the simple name is we can write like this, AM, amplitude modulation, AM process, amplitude modulation process. So the basic block diagram of the modulator, already we have discussed. The modulator requires one signal, that signal is modulating signal. Modulating signal. So please remember one point here, this modulating signal should be always low frequency signal. This is a low frequency signal. And another signal is required, that is carrier signal. Carrier signal. Carrier signal should be high frequency signal. And later it processes the operation, that operation is called modulation process. So after modulation process, then it gives the output signal. That output signal is modulated signal. Modulated signal. See, in communication system, especially in analog communication system, always we have to assume modulating signal as M of t, modulating signal as M of t, carrier signal as C of t, C of t, carrier C, modulating signal M, and the signal is modulated signal. Modulated signal always we have to write with S of t representation. So please remember this representation. So in this subject, if suppose if I wrote S of t, immediately we have to assume that is a modulated signal. If I wrote one functional representation M of t, then immediately we have to assume that is a modulating signal. C of t explains the carrier signal. So please remember these points here, right? So first of all, I am taking here modulating signal, M of t, right? And other signal is their carrier signal, that is C of t. C of t is a carrier signal. just now we have discussed in types of modulation. Carrier signal is continuous wave signal, then the modulation process is called continuous wave modulation. Amplitude modulation comes under continuous wave modulation. That's why here I am taking this carrier signal. Standard equation is continuous time signal, that is sinusoidal signal. That sinusoidal signal is I am taking like this: AC cos of omega ct. Please remember this one. Wherever C representation is there, immediately we have to take that is carrier signal. That parameter is a carrier signal parameter. So here I have wrote AC. AC is nothing but the maximum amplitude of the carrier signal. And what about omega C? Angular frequency of the carrier signal. So always we have to write in this representation. And another important point, please remember that point. Here I have wrote the function is cos function. Right? Otherwise we can take sine function also. Sometimes we can take in this format: AC sine of omega ct, or we can write like this: AC cos of omega is nothing but 2 pi f, right? So 2 pi f ct, or here we can write AC sine of 2 pi f ct. So carrier signal means this signal should be here continuous wave signal, because amplitude modulation comes under continuous wave modulation. Here the carrier signal is fixed equation, the functional representation of the carrier signal is fixed. That equation is either cos function or sine function. AC cos of 2 pi fct, AC sine of 2 pi fct. Here fc explains the carrier frequency of the carrier signal, maximum frequency of the carrier signal, and AC explains the maximum amplitude of the carrier signal. But to write the functional representation, always I want to use the cos function, because this cos function, sine function has one difference. That difference is sine function is odd function and cos function is even function. Cos function is a even function and sine function is odd function. So already we have discussed that the frequency domain representation of even signal is always even spectrum. Right? Frequency domain representation of the even signal is always even. Frequency domain representation of the odd signal is always odd. But in that odd representation, it changes the parameters, like real function becomes imaginary, imaginary function becomes real. That's why now onwards I prefers always carrier signal is nothing but cos function. If you want, you can take sine function also. Right? That is depends on your application. If you want to write the equation in terms of sine function, take this equation and write the complete equation. And generally I prefers always cos function, because cos function is a even function, cos signal is a even signal. The frequency spectrum of the even signal is always even, and it gives the real becomes real, imaginary becomes imaginary. There is no interchanges. But in odd function, real becomes imaginary, imaginary becomes real. That's why now onwards I want to use always cos function. I will write both equations, but generally I use just mostly this cos function representation only, right? So please remember that point here. And here AC explains the maximum amplitude of which signal? Carrier signal, right? And what about FC? FC explains the maximum frequency of a signal, carrier signal. So now onwards I will use cos function representation, right? And what about S of t? S of t is a modulated signal. Now I want to write the definition of AM modulation, amplitude modulation. Now here we want which type of modulation? AM modulation. That's why now I'm taking this circuit is amplitude modulator circuit. Amplitude modulator circuit. So amplitude modulator circuit requires two input signal. One input signal is modulating signal and another input signal is carrier signal. Later it performs a operation. After that process, it gives the modulated signal. The modulated signal is always S of t. This is the standard definition of AM modulation. Amplitude modulation definition. It is the process of changing amplitude of the carrier signal. Amplitude of the carrier signal means which parameter has to change here? AC. This part has to change here. Amplitude of the carrier signal with respect to amplitude of the modulating signal. So now here first of all I am taking C of t signal. C of t is nothing but here carrier signal. The equation explains AC cos of 2 pi FCT. AC cos of 2 pi FCT. So carrier signal is applied here, modulated signal is connected, then we have to write the standard functional representation of which signal? Modulated signal. So modulated signal S of t is now. Which type of modulation is there here? AM modulation, that's why I am writing like this. S of t is nothing but modulated signal. AM modulated signal here. Now, according to this definition, it is the process of changing amplitude of the carrier signal. This is the carrier signal, right? AC cos of 2 pi FCT. So, this is the carrier signal here. The amplitude of the carrier signal is changes. Amplitude of the carrier signal is nothing but AC is changes. It changes with respect to amplitude of the modulating signal. That's why we have to add directly amplitude of the modulating signal is like this. See, modulating signal is here M of t. Modulating signal is M of t. The amplitude of the modulating signal affects on amplitude of the carrier signal. So, amplitude of the carrier signal changes with respect to amplitude of the modulating signal. That's why the amplitude of the modulating signal directly combines with the amplitude of the carrier signal. Then this gives the modulated signal here. And if you want to write in terms of sine function, if you want in terms of sine function, then the function becomes like this: AC plus M of t into sine of 2 pi FCT. If you assume the carrier signal is a sine function, then the equation becomes like this. Then I want to write in terms of standard format here. So the standard format is like this. AM modulated signal output is, I am taking AC is outside here. AC is outside. So then immediately which gives the 1 plus. Here if you take AC is outside, then it becomes here 1 by AC. That 1 by AC is also called as here Ka into M of t into cos of 2 pi FCT, or we can write like this: AC into 1 plus Ka into M of t into sine of 2 pi FCT in terms of sine function, in terms of cos function. See, in amplitude modulation, the frequency of the carrier signal does not vary here. What is the frequency of the carrier signal? FC. This does not affects. So, frequency of the carrier signal is constant. But which parameter changes? Amplitude of the carrier signal changes. So, that's why amplitude of the carrier signal is changing here. Right? Then finally, AM modulated signal equation is AC into 1 plus Ka M of t. Ka M of t into cos of 2 pi FCT, or we can write in terms of sine 2 pi FCT. And here Ka explains the 1 by AC. 1 by AC is also called as amplitude sensitivity. It is also called as amplitude sensitivity. So, this gives the standard mathematical equation of the AM modulated signal. And similarly, we have to discuss here time domain representation and frequency domain representation of AM modulated signal. So,